So this is a concentration calculation, and we're being asked to calculate the concentration. So concentration, as you can see, it's the mass, which is the amount divided by volume. So in this question, we have got 6.52, and we're dividing it by 250, but we must remember to divide that by 1,000. So 6.52 divided by 2, let's put a bracket in there, divided by 250, divided by 1,000, and that is going to give me an answer of 26.08, which is fine. It's not giving me any kind of decimal places to go to, and that's going to be grams per decimeter cubed. Marks wise, you're going to get a mark for showing you're working out here. And then you're going to get a mark as well for remembering that you've got that divided by 1,000 to get the right answer. And why do we divide by 1,000? Because this is in centimeters cubed, and you've got to get that into decimeters cubed. So to get into decimeters cubed, you take centimeters cubed and you divide by 1,000. Okay, next little bit. So sodium hydroxide and copper sulfate reacted together. The resulting mixture, a precipitate of copper hydroxide and in a solution of sodium sulfate. So remember, this means this is a insoluble solid. Precipitate means it's a solid that does not dissolve. Describe how we get a pure sample of copper hydroxide, and how we get a pure sample of the sulfate from the mixture. Okay, let's deal with this in two bits. Let's focus on getting the copper hydroxide. So here, I'm going to write down copper hydroxide. So let's just remind ourselves, what I'm going to have in my beaker is a solution, and inside this solution, I'm going to have an insoluble solid. This solid here is the copper hydroxide, and then the solution is sodium sulfate dissolved in water. Okay, so let's get rid of the copper hydroxide first. So how do you get rid of an insoluble solid? The first thing you would do is you filter the mixture. So you're going to filter this mixture, and what would happen then is that the copper hydroxide remains in the filter paper, okay? And then, if it says the word pure, we have to then describe how we make that pure, and all we would do is we would wash the solid with distilled water, and the reason we can do that is because it's insoluble, so we can wash it without it damaging, dissolving the chemical. And the final thing is we then leave in a warm place to dry. Okay, so that gets the copper hydroxide taken care of. On this side, let's look at the sodium sulfate. So to get sodium sulfate, what we would do is we would evaporate the solution. So we heat it up in an evaporating basin. The water would evaporate, and what would be left behind, leaving the sodium sulfate. And again, all we do is leave in a warm place to dry. So in terms of marks, there's lots of points in there, and every one of those points is going to get you, it is important, and they're going to award, as long as you've got 4 of those points in there, you are going to get the marks for your answer. Okay, next bit down, this figure here shows how we do some electrolysis of the sodium sulfate solution. Give 2 reasons why graphite is a suitable material for the electrode. So the reasons we know this is because, number one, graphite conducts electricity. So graphite, if you remember, contains delocalized electrons, which are free to move, so it conducts electricity. And the next one is that graphite is inert, which means unreactive. So it's not going to take part in the actual reaction itself. Okay, next little bit. Sodium sulfate contains ions. Which ions are attracted to the positive electrode during electrolysis? So let's just have a quick look at this. Sodium sulfate solution. So because it's sodium sulfate, we will get sodium ions and we would get sulfate ions. Because it's a solution, remember means it's dissolved in water. If it's dissolved in water, we'd also get H plus and OH minus ions. So what's going to be attracted to the positive? Well, opposites attract, so we're going to get the negatives attract to the positive, so they are my negatives. So hopefully one of my answers is sulfate ions and hydroxide ions, which it is, it's option D. And the last little bit, I've left the answers in from earlier on. Last little bit says draw a straight line from the electrode to product during electrolysis. So we need to remember a rule in this process here. So at the anode, so for these two here, these two anions here, let's get a different colour pen. These two here, the rule is the simplest is oxidized first, which is going to be the OH minus, because that's only got 2 parts to it, O and H. The sulfate has got 1 sulfur and 4 oxygens, so it's got 5 parts. That's more complicated. So the hydroxide goes first, and when you react to hydroxide, it's actually going to produce, you start to get oxygen being formed at that point. So the anode, hopefully, it matches what we've already got. The anode is going to show that you're getting the oxygen. At the cathode, it's a little bit different. So at the cathode, here now is the least reactive goes first, and hydrogen is less reactive than sodium. So what's going to get formed here is you will start to get hydrogen gas, which at the cathode you can see we're getting hydrogen gas being formed.